Hi all, welcome to our class. Let us discuss the perimeter of a sector. So we have studied area of a sector. Area of a sector is equal to pi r square theta by 360. That is area of this is the sector. So area of the sector is pi r square theta by 360. So what about perimeter of this sector? So theta is the central angle, r is the radius, and this is the length of the arc. Here an arc, length, then these two are the radius. So we know perimeter of the sector means the total length, that is r plus l, that is l plus r plus r 2r. So perimeter of a sector is L plus 2R if R is the radius and L is the arc length. So we have one more formula for perimeter. Perimeter P is equal to pi R theta by 180 pi R theta by 180 plus 2R. Pi r theta by 180 plus 2r. Instead of this L, we can give pi r theta by 180 plus 2r. So perimeter is equal to pi r theta by 180 plus 2r. That is the perimeter of that sector. Now let us consider. So these are the two formulas for finding the perimeter. Now we have area. Area is pi r square theta by 360, or we have one more formula for finding area. Area is equal to 1 by 2 into L into R. If we have arc length and radius, then area is equal to half into L into R. That is, we have pi r square theta by 360 or 1 by 2 into L into R. So area is equal to pi r square theta by 360 or half into L into R. Perimeter is equal to L plus 2R or pi r theta by 180 plus 2R. That means L is equal to pi r theta by 180. Now we can discuss one more formula, that is about the area of a triangle in this sector. For example, we can consider a chord joining two points A and B. So area of triangle OAB. Suppose this is the center O, then we have triangle OAB. So this is a segment, this is a triangle. So the complete is a sector. This portion is a segment. This is a triangle. This triangle plus this segment is a sector. So let us find the area of that triangle OAB. Triangle OAB is equal to, we have a formula for finding. If R is the radius and theta is the center angle, so we can find area of the triangle is equal to half into r square into sin theta. Half into r square into sin theta. So r is the radius and theta is the angle related to the sector. So area of triangle OAB is equal to half into r square into sin theta. So in order to find the area of this segment, if we had to find the area of this segment, this is a segment. To find the area of this segment, we can find the area of this sector, that is the full portion, minus this triangle, then we will get this portion. So we have to find the area of this triangle. So the formula for finding area of triangle is equal to half into r square into sin theta. So we have studied formulas. Perimeter is equal to L plus 2R or pi r theta by 180 plus 2R, that is the perimeter. Area is equal to half into L into R, that is area of a sector. Then area of a triangle is 1 by 2 r square sin theta. These are the formulas we have to understand in order to do the problems. Next problem, a chord of circle of radius 10 centimeter, certain a right angle at the center, find the area of the corresponding minor segments and major segments. So, let's look at the chord AB. So, AB divides this circle into two parts. This is the one part and this is the second part. So, this portion, this is a segment, this is also a segment. So, this small portion is known as minor segment and this chord and the remaining arc, this portion is known as major segment. So, we have to find the area of this minor segment and this major segment. We know the radius is 10 centimeter. So, we know we have to find this portion. So, look at this radius, these two radius, this is the length of the arc. So, this is a sector. So, we know how to find the area of a sector. So the full portion is area of the sector. Then we need only this portion. So, from the area of the sector, we can subtract this triangle. Then we will get this portion, that is area of the minor segment. So, first question, area. Area of minor segment which is equal to area of sector minus area of this minor sector minus area of triangle OAB. Area of triangle OAB. So, which is equal to, we know area of circle which is equal to pi r square theta by 360. Pi r square theta by 360 minus area of triangle OAB. We have studied area of triangle half r square sin theta. Half into r square sin theta. So, which is equal to pi r square theta by 360. We know pi is equal to, take pi is equal to 3.14. Take pi is equal to 3.14. In question, it is given that pi is equal to 3.14. So, we can use 3.14 instead of 22 by 7. So, 3.14 into r square 10 into 10 into theta is 90 degree by 360 degree minus half. R is 10, so 10 square, 10 into 10 sine 90. Theta is 90, so sine 90. So 3.14 into 10 into 10 by 90 by 360, 1 by 2 into 10 into 10 into sine 90. We know sine 90 is 1. So 3.14 into 10 into 10 by 4. We can cut this 90 and 360 4. So 3.1 into 10 into 10 by 4 minus 1 by 2 into 10 into 10. So we will get 78.5. When we simplify this, we will get 78.5 minus 50. 10 into 10, 100. 100 by 2, 50. That is 78.5 minus 50. That answer is 28.5 centimeters square. That is the area of this minor segment. Now we have to find the area of major segment. Area of major segment which is equal to, we know area of major segment means this portion. So if we have the complete area of the circle, then if we subtract this portion, then we will get the rest of the portion, that is the minor segment, area of this minor segment. So area of major segment is equal to area of circle. Area of circle means full area minus area of this segment. Area of minor segment. Area of minor segment. Area of minor segment. So which is equal to area of circle, you know, pi r square minus area of minor segment we got 28.5. 28.5. So pi is equal to 3.14 into radius 10 into 10, which is minus 28.5, that is 314 minus 28.5. The answer is 285.5 centimeter square. 285.5 centimeter square. So major segment, area of major segment means full area minus this minor segment. So area of major segment is 285.5 centimeter square. Next question. In a circle radius 21 centimeter, an arc subtends an angle of 60 degree at the center. Finds the length of the arc. Second one, area of the sector formed by the arc. Then area of the segment formed by the corresponding chord. So we have a circle. This is the center. Angle is 60 degree. So we have to find the length of the arc. So we have the formula L is equal to pi r theta by 180. That is arc length. R is the radius and theta is the angle. Then length is equal to arc length is equal to pi r theta by 180 degree. So which is equal to pi 22 by 7. We can use 22 by 7. R is 21. Theta is 60 by 180. So we can cut 6, 7 and 21. That is 3. Then 180 and 60. That is 3. Then let us cut this 3 and 3. We will get 22. So length of the arc is 22 centimeter. So our first portion is our the length of the arc L is equal to 22 centimeter. That is the length of the arc using the formula pi r theta by 180 degree. Next one is area of the sector formed by the arc. Area of the sector. Second question, area of the sector. That we know pi r square theta by 360. Using the formula pi r square theta by 360 degree. So we know pi is equal to 22 by 7 into radius 21 into 21, and theta is 60 degree by 360 degree. 360 degree. On solving this, on calculating this, 22 by 7 into 21 into 60 by 360 degree, calculating we will get 231 centimeter square. 231 centimeter square. That is the area of the sector. Then area of the sector. We have this area. Full area is area of the sector. Now we have to find the area of the segment formed by the corresponding chord. So consider a chord. We have to find this area of this segment. Then we have already studied how to find the area of this minor segment. That is area of the sector minus area of the triangle. So area of triangle, we know the formula half r square sin theta. So area of triangle. Area of triangle is equal to half into r square sin theta. That is the formula. R is the radius. That is which is equal to 1 by 2 into r square. 21 into 21 sin theta. Sin theta is sin 60. Sin 60 is root 3 by 2. That is sin 60, which is equal to 1 by 2 into 21 into 21 into sin 60 is root 3 by 2. Root 3 by 2. So that is 1 by 2 into 21 into 21 into root 3 by 2. So we will have 2. We will get 190.9. Area of a triangle. On calculating this, we will get 22 into 21. 21 into 21. So and into root 3. So we can give the value of root 3. then divide by 4, we will get 190.95 centimeter square. So area of this segment is equal to area of sector minus area of this triangle. That is area of segment equal to area of triangle minus area of sector minus area of triangle, that is 231 minus 190.95. So the answer is 40.0. 40.05 is centimeter square is the area of this corresponding segment. Next question. A brooch is made with a silver wire in the form of a circle with the diameter 35 meter. The wire is also used in making 5 diameters, which is divides the circle into 10 equal sectors as shown in the figure. So a brooch is made with a silver wire. A silver wire, diameter is 35 millimeter. Diameter is 35 millimeter. So the wire is also used in making 5 diameters. Here also using that wire, first using the wire we made a circle, then again using that wire we are making 5 diameters. Thus divide circle into 10 equal sectors as shown in the figure. Then we have to find the total length. Total length of the wire required, of the silver wire required, of the silver wire required. Total length of the silver wire required, that is the first question. Second one, the area of each sector. The area of each sector. The area of each sector. So we have to find the total length of the silver wire required. So we have to add the length of the total wire. That is this length plus or this 5 diameters length. So we have length of 1 diameter. Length of 1 diameter is equal to 35 millimeter. So the total length of here 5 diameters are there. So total length of 5 diameters. Total length of 5 diameters, which is equal to 5 into 35 millimeter. 5 into 35 millimeter is equal to 175 millimeter. 175 millimeter. So we have the total length. We got all this length. Now we need this length. That is the total length of the wire used. So we have 175 millimeter is the total length at the length of the diameter. So 5 diameters are there. 1 diameter is 35 millimeter. So total length is of diameter is 175 millimeter. So we need the total length of wire used. So we have to find the circumference. Then we add these two. We will get the total length of the wire. So circumference of the circle, that is 2 pi r is equal to 2 pi r is equal to 2 into 22 by 7 into radius. Radius is diameter is 35, so radius is 35 by 2. So we can cut this 2 and 2, 7 and 35, 5, that is 22 into 5, 110 millimeter. 110 millimeter. So we have circumference, that is this length, plus we have also the total length 175 millimeter. So total wire used, length of wire, total length of wire. total length of wire is equal to 175 plus 110, that is 175 plus 110, that is 285 millimeter is the total length of the wire used. Now we have to find area of each sector. So we have 10 sectors. So the total angle is 360 degree. So angle of one sector which is equal to 360 is the total angle. So one equal parts, that diamond divides this circle into 10 equal parts. So one angle of one sector is total 360, 10 equal parts. So one angle of one sector is 360 by 10, that is 36 degree. So we have one angle is 36 degree. So area of the one sector which is equal to, we have area of sector is equal to pi r square theta by 360. By 360 we have pi is equal to 22 by 7 into radius is 35, so 35 by 2. Therefore r square means 35 by 2 into 35 by 2. Then theta is 36 degree by 360 degree. So when we calculate this, we will get 22 by 7 into 35 into 35 by 2 into 2 into 360 degree. So when we cut this, we will get 385 by 4. 385 by 4 milli area. Area is meter square, millimeter here. Count is millimeter. So 385 by 4 millimeter square is the area of one portion. That is 385 by 4 millimeter square is the area of the sector.